In today's lesson, we are going to be looking at the sine law. So again, this should be a little bit of review from grade 11 and maybe even grade 10, because you should have looked at sine law in one of those years. Maybe not grade 10, depending on what course you took, but essentially in grade 11, you should have at least covered this. So what we're going to look at, again, sine law, we have the sine law here. So it is given to us. Basically, it's a ratio between sine of an angle and the opposite side. And then it works out that all those sides, or the ratios, are equal to each other. So you can set up an equivalency between all of those ratios. Now, again, there's two different forms. Generally speaking, if you're trying to find the angle, it would be on top. So this would, first one here, this would be for angles. This would be for sides, finding sides. Realistically, though, either one works. As you go through it, you'll see kind of how the steps are going to be the same. So it's not really going to change much. We do have our triangle labeled here. It is a non-right triangle because, again, for sine law, it is for non-right triangles only. Well, I guess I shouldn't say that. You can use it for right angle triangles, but the amount of work that you have to do to solve, it's easier to use the right angle trig rather than using sine law. So you can use sine law for both, but I would say sine law is more used for non-right angle triangles. One of the key things is, because we're dealing with an angle and its paired side, we want to make sure we understand that if we have an angle B and a side B, they're across from each other. Right? Angle A and side A, they're across from each other. Angle C and side C, they're across from each other. You want to make sure we're aware of that because we do have to understand the pairs that come up. Now, there are a couple steps to go through. So again, we're just going to go through the steps and then we'll put it into practice. So first thing, you want to make sure that you are dealing with a non-right triangle. Because if you're dealing with a right angle triangle, you might as well just use your regular trig ratios that we've talked about previously. So make sure you're dealing with a non-right triangle. You can write out the sine law using the given labels. Plug in everything you know. You're going to get rid of the ratio that you aren't using. So essentially what you need is a complete ratio and the ratio that contains the side or angle that you want. Essentially what we're going to be working with is a full pair and a half pair. And we'll look and we'll talk about that as we go through the examples. And then we're going to use cross multiplication and our calculator to solve for the side or the angle. So again, we will look through those examples so you don't have to worry about that. So one thing before we get into it, if we look at this following triangle, it is a right angle triangle actually, because this does work out. But aside from that, if we look at the ratios, so the ratio of the angle with its side, so A and side A, C and side C, what do we see about the ratios? So sine of 60 divided by 17.3. We should find for that we get 0.05. And then sine of 30 divided by 10, we get 0.05. So we see that the ratios of the sides are equal. Sine 30 over 10 is equal to sine 60 over 17.3. So what we should notice is they are the same. Oops. They are the same. And does this work for all triangles? Yes. Because again, that's what the sine law is. This is what the sine law is saying. The ratio of the angle and its side is equal to the ratio of the other angle and its side. So it is a property of these triangles. That's how this law kind of works. So what we want to do now is we want to solve the following triangle. When it says solve for the triangle, it means to find all angles and sides. So we want to make sure that we've found all the angles and all the sides. So we're missing 2 angles here and 1 side. But let's look at first the information that we're given. So this is where understanding the pairs comes into play. So right now we have 1 pair here, and we have half a pair here. So that's what we're going to be working with. So I'm going to write out my sine law. So sine A over A equals sine B over B equals sine C over C. Now which ones are we going to work with? Well, we can see that if we're going to plug information in, we have information for A, because we know the side length, or little a. For B, we don't know anything. And for C, we know the angle. And we know the side. So there's 1 pair that we don't know anything about. So in that case, we don't need this middle ratio. We only need the one with C and the one with A. Again, you can also think of we don't need that third one because we can't really have 2 sets of equal signs in one equation. So once we figured out what 2 ratios we're dealing with, we filled everything in, the next step is to cross multiply. So we end up with 15 sine A is equal to 11 times sine 75. And if I want to get sine A by itself, this 15 needs to come over. It comes over and becomes division. So we get sine A equals 11 sine 75 divided by 15. And then the last step, we could go through and solve this. Last step though, to get A by itself, I need to move the sign over. It becomes sine -1 of 11 times sine 75 over 15. So a lot of work kind of there to rearrange everything, but it is going to be kind of the same steps. Cross multiply, move something over, divide out. And then if we need to find the angle, we'll have to use the inverse. So if we go through and calculate this, 11 times sine of 75 divided by 15. We should get, actually let me just make this a little bit smaller so I can fit everything here. We should get sine of -1, or the inverse of sine, and 11 sine 75 times divided by 15 should work out to roughly 0.708. So make sure you are getting that number, just make sure your calculations are good. Then when we do the inverse sine of that answer, we should get an angle of 45 degrees, or 45.1. Now, to find the other missing piece, or pieces, to find that missing angle, I can just use the quick calculation of 180 minus 45 minus 75, because all angles need to add up to 180. So rather than going through and doing the sine law again, you can find that this angle is 60. In order to find, though, this missing side, or little b, I do need to go through and use my sine law, right? Because I do have half a pair here, so I do need to go through and use that sine law. So we're going to shorten it a little bit because we're only going to write down the 2 sides we're dealing with. So sine A, or sine B, sorry, or C, sine C over little c, and sine B over little b. Sine C is sine 75 divided by 15 is equal to sine 60 over little b. Once we've filled out all the information, we cross multiply. We're left with b sine 75 is equal to 15 times sine 60. I then have to move the sine 75 over and divide that out. So 15 sine 60 divided by sine 75 is going to equal my side length. So hopefully we can start to see a pattern between the steps that we're going through. Right? The only difference with this one, we're not trying to find an angle, so we're not doing the inverse of anything. So 15 sine 60 divided by sine 75 gives us a final answer of roughly 13.45. So we now know then that b is 13.45. We have all the other information, so we've solved the following triangle. We're going to do the same thing, but we're going to solve an obtuse angled triangle. Right, so again, try to go through these steps on your own. Right, I will pause the video to give you a chance. We'll get you started first. So again, recognize what pairs we have. Right, actually, change up the colors. Recognize what pairs we have, because that will help us at least fill it out. So again, I'm going to challenge you to try to do this one on your own. I'll pause the video, you can pause the video, and then we'll come back with the answers. So this one was a little bit trickier, so I do apologize if you were trying to go through it and you got stuck. So with the angles or the pairs that we were given, we were able to go through and we found that A was equal to 53.4. However, looking at angle A, we can see that angle A is actually an obtuse angle. So it shouldn't be 53.4 degrees. That doesn't make sense. This is where something similar to what we looked at in the last lesson comes into play. Right? In the last lesson, when we were looking at standard form, we saw that sometimes with sine, it doesn't quite give us the exact angle, but it gives us the supplementary angle to it. Basically, it gives us the angle that when you add it with the actual angle, you get 180 degrees. So, because we know that this angle is obtuse, we need to take the angle we found, or this answer, and subtract it from 180 to get the angle, to get the actual angle, which in this case is 126.6. So a little bit of an added step, and you want to be careful when you're dealing with obtuse angles, because you might have to do that step if you're given an incorrect angle, or using common sense, the angle seems too small. So once we do that, we then can figure out our last angle by subtracting all of them from 180, and then given the angles that we know, or the pairs that we know, we can find that missing side by again using sine law again, which we see over here on the right. We should find that that missing side is 8.3. So again, you want to be careful when dealing with obtuse angles. So you just want to be careful with that. Right, so just make sure you make a note if the angle or the triangle is obtuse. What we're going to look at now is we're going to look at some examples. So again, it will be helpful if we can draw these examples, or at least visualize them, because then it's relatively straightforward, hopefully, to figure out what our actual measurements are going to be and what our laws or what our formulas are going to look like. So a weather balloon is located between two tracking stations. It has an angle of elevation of 62 degrees from one tracking station and an angle of elevation of 47 degrees from the second tracking station. The tracking stations are 3 kilometers apart. So just start, we're just going to draw our two tracking stations. So maybe they're just houses. So we have our two tracking stations. There's one. Oops. There's another one. They're 3 kilometers apart. And we have our weather balloon that's floating up in the sky. Maybe weather balloons look a little bit different. Maybe something like that. And then you got a little box hanging down from it that's recording information. So there's our weather balloon hanging between our two weather stations. We're then told that the angle of elevation from the first weather station, or from the first station, is 62 degrees, and from the second station it is 47 degrees. So there is some information that we can go through and find, because we want to figure out how far is the balloon from the first station. So we want to figure out this piece of information. Well, in order to find that, we can't assume that it's a right angle triangle, because we don't know what angles make this up, but we could figure out this missing angle, 180 minus 47 minus 62. We should get 71. So we should get 71 degrees. So clearly we can see it's not a right angle triangle. So that means we must use a different law or a different formula. Because we only know sine law right now, that's what we're going to use. And if we go through, we do see, actually let me use a highlighter. We do see a pair and half a pair. So we have a full pair, we have half a pair. We should be able to go through and use our sine law. So again, do sine of 71 over 3 is equal to sine of 47 over x. And again, realistically, it doesn't really matter if you have the sides on the bottom or sides on the top. The steps are still going to be the same. You're still going to cross multiply. So we get x sine 71 is equal to 3 times sine 47. I'm going to move the sine 71 across. We get x is equal to 3 sine 47 divided by sine 71. And when we go through and solve, we should find that x is equal to 2.3. So that means that the distance from the first first tracking station to the balloon is 2.3. Same question, B is now asking, what is the height of the balloon? So I'm just quickly going to redraw the triangle. I'm not going to go through and draw everything out fully. I'm just going to go through so I can label all my key pieces of information. So I have 62 degrees, 47, 71, 2.3, and 3. And I now want to know, what is this height? What is that height of the balloon? Well, this now gives me a right angle triangle. So if I were to look at that separately, that right angle, I'm looking for that unknown height. I know the hypotenuse, or the diagonal, is 2.3, and I know the angle is 62. So I have enough information here to go through and use my trig ratios. So based off of this given angle, we have the opposite, we have the hypotenuse. If we want to label the adjacent just for practice, we can. Because we're dealing with the opposite and the hypotenuse, that means that we should be using the sine ratio. So sine theta equals opposite over hypotenuse. Sine 62 is equal to x over 2.3. And we said that when we have the missing piece on the top, we bring the 2.3 up and we multiply. So 2.3 sine 62 equals x, and we should get 2.3 sine 62 should roughly 2.03 kilometers is equal to x. So that is how high the balloon is. So the balloon is 2.03 kilometers high. In another example, two ships, the Albacore and the Baffin, leave port at the same time in different directions. The Albacore traveled a distance of 40 miles, and now the distance between the two ships is 70 miles. A radar reading aboard the Baffin determines the angle between the Albacore and the port is 24 degrees. At what angle to each other did the two ships leave the port? So this one might be a little bit difficult to draw out, but let's start out quite simply. So they both leave the port heading in different directions. So let's say we have our port down here. So we'll say this is our port. Maybe we'll put kind of like a dock. Maybe what looks like a small little lighthouse. So we have our lighthouse. Maybe it almost looks like a chess piece. I'll draw a little light beams coming out. So we have our port. We have our two ships then going in two separate directions. So one is, let's say, is going this direction, one is going in this direction. There then, so let's say we have the Albacore, so we now have to draw one of our boats. So we have one boat here, we have another boat over here. So let's say, maybe we'll make this one, I don't know, let's make it like a submarine, just for sake of argument. So we have our submarine, we have our boat. So if we can see how our triangle is formed now. So again, it doesn't really matter which one is which, but we can say that, let's call this one the Albacore, let's call this one the Baffin. So the Albacore traveled 40 miles. Now the distance between the two is 70 miles. And we know that for the Baffin, the reading between the Albacore and the port, so between the Albacore and the port, so this angle here is 24 degrees. We want to figure out, what is this angle here? What is the angle that they left at? So there's a couple things we need to do first. First of all, in order to solve this, we do have a full pair and half a pair. So that should be enough to help us solve this. So now, again, we can go through and label. We can start off with sine of our angle, say 24 over the corresponding side, which is 40, is equal to sine of unknown, we'll say, call it P, divided by the side, which is 70. So even if you don't have it labeled as specific sides, as long as you fill it out so that it's a ratio of the angle to the side, that's fine. Once we fill it out, we're going to cross multiply. We get 70 sine 24 is equal to 40 sine P. I want to move the 40 over, so it becomes 70 sine 24 divided by 40 equals sine P. To get rid of the sine, or to get P by itself, it becomes sine negative 1 of 70 sine 24 over 40, which will equal P. So going through and solving this, 70 times sine 24 divided by 40, and then the inverse of sine of that answer, we get that P is 45.3 degrees. But does that make sense? Does that look like what our angle is? In this case, no. Because they're heading in two different directions, it needs to be an obtuse angle. So angle P has to be or should be obtuse. So since that's the case, we have to take 180, or take our angle and subtract it from 180. And we get 134.7 degrees. So that is our final answer. So that is the angle between the two ships as they left. So therefore, the angle is 134.7 degrees. Draw it over our lighthouse there. B wants to know, how far did the baffin travel? So I'm going to just draw it out roughly again. I'm not going to put too much effort into the actual drawing. So we have 134.7. We have wrong one. We have 24 degrees for our angle here. We have an unknown angle there. We know that this is 70 between them. We know that the albacore traveled 40. We have the baffin. And we want to figure out how far did the baffin travel. Well, based on what we have, we can go back to what our full pair was at the beginning. I'm going to go back to this full pair. And the reason I'm going to stick with that one and not the other one is because I know for sure that this angle and this side are the same. Right? I'm not 100% sure that I got 134.7 correct. Maybe I did a calculation wrong. So I don't want to use that pair just in case I got that angle wrong. If I got that angle wrong, then it might mess up my calculations. Because I'm looking for X, or this side, I need to have my angle there. I need to figure out that angle to have half a pair at least. So I am going to have to use the other angle. So 180 minus 24 minus 134.7. Gives us an angle of 21.3 degrees. Now I have enough information to go through and solve. So, sine of the angle, 21.3 over the unknown x is equal to sine 24 over the side of 40. Again, once we fill it out, we cross multiply. So 40 sine 21.3 equals x sine 24. When I get x by itself, this sine 24 comes over. 40 sine 21.3 divided by sine 24 will equal x. And then we get as our final answer that x equals 35.7 miles. So therefore, the baffin traveled 35.7 miles. So again, just an example of, again, finding a side length. We've looked at examples of finding sides, or sorry, angles as well. You just want to make sure that if you have an obtuse angle, make sure you are aware that it is obtuse. And if your angle does not show that, chances are you probably have to subtract it from 180. But make sure you double check your calculations just to make sure that everything is done correctly. And then you can subtract it from 180. So again, looking at sine law, that is one way that we can find sides and angles for non-right angle triangles. There is another law that we could use for other scenarios, but for right now, just focusing on sine law.